Welcome back to Well, That's Interesting. It's good to have the whole thing, but this is okay too, I guess, edition.
What are we missing? What whole thing? Is it like a loaf of bread versus a slice? Is it like a whole leg versus half a leg? Are we talking body parts?
You're getting closer. Yes.
Okay. Now I'm worried.
Today is episode 090. 090. 90. Missing part of your brain? Not a problem. Sometimes.
That's pretty bad. I mean, I know for a fact I have poisoned away parts of my brain. Cells, at least.
Sure.
I have killed cells.
Oh, yeah.
Many cells.
Right behind you.
The fact that I can still speak and see and hear is a miracle.
Oh, yeah.
A miracle.
It
so
really
much
is.
poison has gone into this body. But we're not talking about me. We're talking about the brain.
Talking about the brain today.
Yeah.
It is a huge episode today because we reached 090.
We have.
It's fucking crazy.
We so have. Is it that crazy, though?
Oh,
I
yeah.
think it's...
90 full goddamn episodes.
We did it.
Thank you to everyone who's been around since 001, man.
Y'all, we couldn't have done
God
this
bless you.
without y'all. If y'all weren't here, we would be just talking.
killing more brain cells with something else.
We would be killing a lot more brain cells. But we're saving them so we can do another 90.
That's right.
Was that too heartwarming?
That was
pretty disgusting.
That was
I'm
pretty
sorry.
disgusting. You should be. I'm Jill Chacha, and I am with the disgusting Marissa Riley.
That's me. I am so gross. I am so sorry. I will keep it very sarcastic and apathetic going forward.
Wonderful.
Yes.
If this is your first time listening, welcome to the flock.
Welcome.
Dr. Riley here comes in cold and learns everything in real time, just like you.
It's true. I had no idea what we were going to talk about today. And now that I do, I am immediately looking inward at myself and wondering if I am also missing part of my brain.
Oh, yeah. That's going to happen today.
I'm going to lose it today. How is that going to happen?
The introspection.
You taking it through my nose?
Oh, I'm glad you brought up nose. That's really funny.
Oh, my God.
Oh, that's weird, man.
No, I'm really worried.
Oh, that's weird. Yes, my friends, today we have two incredible stories based on two incredible studies of people flat out missing actual sections of the brain.
Wow.
But you'd never know it.
Wow.
Yeah. In the first half of the show, hold on to your butts.
You got it.
Because we'll be talking about some folks born without the olfactory part of their noodle, but can...
I don't know what olfactory means. I hope you tell me.
But they can absolutely 100% smell every goddamn thing around them. Olfactory.
Olfactory is smelling?
Yeah.
Oh.
There you go.
Okay. Yeah. I could do without smell.
No.
Come on. Of all the five senses, what is the one you could do without?
Oh my God.
Isn't that hard?
That's terrible.
And I love smelling.
Yes.
I love smelling.
So yeah, she's like, I could do without smells. Like you just bought a canister of like little incense.
I have so much incense in this house. I'm not like a spiritual person either. I just like the way it smells. Yeah. I like to fill my room with smoke.
That's right.
That smells pretty. But no, of all
Classy
the five
bitch.
senses, I would remove smell. What would you remove?
Oh. Well, we're going to talk about how important scent is, actually.
Okay.
And you may want to keep it.
Okay.
Yeah, I know.
But then I wouldn't have to smell other people's farts on the elevator.
Okay.
Or
I like
the
this.
train. Or I wouldn't have to smell my own farts. Yeah. I would live.
Okay, so farts are in your the first thing.
Yeah.
Okay, I got it. Okay.
Yeah.
Let's continue.
That's the one.
So that's going to be the first half of the show,
Wonderful.
everybody. And then after the break, we'll talk about a woman who has no left temporal lobe.
Oh, that sounds important.
Yeah, but But she is fluent in languages and speaks perfectly fine.
Okay.
We're going to cover what that lobe does, of course, and how the olfactory works, because honestly, you have to know how it works to realize how incredible it is that these folks are totally fine without one or without the other. They're okay.
Okay. So I'm going to say something that I don't know if everyone's thinking this, but I don't know if anyone knows just how true it is, but they say you only use, 10% of your brain? I don't know who they are. We've been saying this phrase forever, but I don't know if it's even close to real. Do you know anything about that?
We use every square inch.
Okay. That's what I thought.
Sure. That's for sure. We need to.
Yeah.
We're going to find out today just how incredible our brain is. It's just mind-boggling. These are just two instances of how it just needs to survive. It's insane. It's insane. And I'm getting ahead of myself.
I'm so excited.
Okay, so let's dive in. And to do so, we need to travel back in time to that very special year. You know the one no one remembers. You're moving it.
I was getting ready.
You want to say it together?
Yes. 2019.
That's right. The year no one remembers.
It's officially turning into my favorite year because everything that we talk about happens.
It's
if we're not
crazy.
talking about butts, we're talking about 2019. That's what we should rename this podcast. Well, that's butts or 2019. Should I make a sticker?
Yeah, we'll revamp on
I'll put it on a tote. We have so many totes to make.
So many
totes.
Just drowning in fucking totes. So it's 2019, and this year was the year several researchers from the Department of Neurobiology at the Weizmann Institute of Science in Rehavat, Israel, they just published their findings in the November issue of the journal Neuron.
Cool.
You know the one.
Yeah.
And they admitted in this journal that, as with a lot of findings, they discovered, what their discovery was. It was completely by accident.
I love an accidental finding.
Yes.
That's so fun.
Now, while reviewing MRIs of healthy, left-handed female volunteers for a study focusing on smell in this population, the team came across an image of a brain that was completely missing what's called olfactory bulbs.
Cool. Okay.
Even though, remember, this person volunteered to smell stuff.
Interesting.
The volunteer was like, yeah, I'm totally fine. What's up? Are we smelling shit or not? Are we doing this study? What's happening? So it turns out, no. The researchers scrapped the initial study ASAP and dove headfirst, no pun intended, on finding more healthy, totally have their sense of smell, left-handed female volunteers without olfactory bulbs. Okay, put a pin in that.
Okay. I have lots of questions. I have a feeling you're going to answer them before I ask
What's
them.
up?
Tell me, I really want to know what an olfactory bulb is.
Yes.
I'm not left-handed, but
Yeah.
I hope I have them.
Oh, yeah.
Although it sounds
we're
like
gonna
you
get
could
stats.
survive without them.
Oh, yeah, absolutely. Absolutely. Now, like we said, before we get into what tests are going to be performed on this population, what the outcomes were, Dr. Marissa had a great question. What the fuck are these bulbs?
Yes.
How do they work? Am I missing this body part? All great questions. So let's get acquainted with your new best buddy, the olfactory bulb.
You got it.
So please, everyone, imagine your face.
Oh, sure.
Now, point to the space between your eyebrows.
All right.
Just above your nose.
Okay.
And voila, there, behind your skull, you'll find two bulby shapes, one for each hemisphere of the brain.
Cool.
And boy, howdy, they are itty bitty things, okay? According to the American Journal of Neuroradiology, they're between 6 and 14 millimeters long. That's just 2/10 of an inch to 1.5 inches long for us Americans.
That's so tiny.
Yeah.
I feel like that would take
2/10 of an inch.
6 margaritas to just completely dissolve.
There you go.
In my mind, I'm like, I totally
It's like 2 lines.
fucked these up. Yeah. I lost these at 17 on a bender. I'm sure that's not how it works. I'm just laughing. But tell me more.
So they're between 6 and 14 millimeters long. They're only 3 to 7 millimeters wide and just 2 millimeters thick. That's it. 2 millimeters thick is a barely existent 7/100th of an inch. So that's for the Americans. But let me tell you, These little things are jam-fucking-packed.
Ooh.
Dr. Marissa, I have a color-coded photo of a mouse's bulb.
Oh.
They're very similar to ours, and would you like to see it?
Yes, please, hurry.
And all photos, MRIs, scans, the whole thing, they will be on our social media stuffs because you will want to see these people's brains and bulbs.
Oh, they're so good. You want to see it.
Yes.
I haven't even seen them yet.
So please come on by. Take a look at this mouse's bulb.
Okay.
Dr. Marissa, what do you see?
Okay.
And of course, just for reference, each color you see is a separate layer of cells.
I mean, it looks vaginal.
Yeah, it does.
But I try to make everything look vaginal. It sort of looks like a stretched out, like a bean or like like a zucchini shape. That's the middle of it. So basically the middle, what I'm looking at is this kind of green zucchini shape.
Yeah.
And then, and it's kind of it's spotty, like as if you took a sponge with some paint and then mushed it on the wall. It'd be this kind of spongy looking thing. And then around it is sort of another sort of like spongy line of red. And then around that is a layer of mostly black with red flecks. And then around that is a blue layer, and again, that's also that kind of spongy effect. And each layer is a totally different texture, a different color, and this looks very special and vaginal. Both of those words mean the same thing. So, yeah.
I totally agree. Think of it as an onion, and when you peel back one layer, you find another and another and another.
Exactly.
I mean, so far, researchers have found 5 distinct layers in these bulbs, and each performs a role in taking one even tinier scent molecule, turning it into a signal, and passing that signal along to other areas of the brain, who in turn translates the information, and that makes us perceive a smell.
Cool as fuck.
That's right.
That's cool as fuck. I love it.
It's fucking insane. But, you guessed it, it's even more complicated than that.
Of course.
And we have to break this down just
right.
so you can really get a sense. Dr. Marissa, would you like to join me on this journey? Would you like to take turns reading about what we know about / how we think the sense of smell works? Because we're not too sure, but this is a general idea of how it works.
I mean, nothing would make me happier because I am, like I said, I nixed it earlier, but like, I am so obsessed with smell in terms of like self-care bullshit. Like, I love a lotion.
Oh, yeah.
I love a perfume. I love a candle. I love a deodorant. My deodorant is unscented right now and it's killing me. Is it working? I don't know. I love a rose spray. I'll stop listing things that I can actually physically see right now.
Is that what you were doing? I was wondering.
Yeah. Just pulling shit out of her ass.
When is she gonna stop? She just keeps going.
This is so disgusting. I like the way your face smells, which is the creepiest thing I tell Jill all the time, but she has the most distinct face smell.
You've heard it here first.
Yeah.
You
guys get jealous. This lady has a good face smell. But yeah, and I'm just attracted to that kind of stuff.
Aww.
So I'm curious to see how that works.
Well, let's begin. Let's find out
Sorry for being disgusting. Barf again.
Fucking gross. All right, so let's talk about the bulb's importance in the grand scheme of things. Our source today is from Alison Marin Curley's article called Making Sense of Sense. Oh, there you go.
What a delayed reaction I had.
Over at brainfacts.org. I had to read that slowly because I was going to say brainfarts.org, but it's brainfacts.org.
It looks like farts. It's one letter off. If someone owns
if someone owns brainfarts.org,
DM us. Maybe we can collaborate.
Or brainfart.org.
Yeah, that needs to be a website ASAP.
Jeez. Okay. So, Dr. Marissa, just take it away, please.
I would be happy to. All right, quote, smell begins at the back of the nose where millions of sensory neurons lie in a strip of tissue called the olfactory epithelium.
Nice.
Epithelium. The tips of these cells contain proteins called receptors that bind odor molecules. Take it away, Jill.
Yeah, people have about 450 different types of olfactory receptors.
Holy mama.
Each receptor can be activated by many different odor molecules. Each odor molecule can activate several different types of receptors. What we think of as a single smell is actually a combination of many odor molecules acting on a variety of receptors, creating an intricate neural code.
Ooh, a neural code. All right. Continuing the quotes. This neural code begins with the nose's sensory neurons. Once an odor molecule binds to a receptor, it initiates an electrical signal that travels from the sensory neurons to the olfactory bulb, a structure at the base of the forebrain that relays the signal to other brain areas for additional processing. One of these areas is the piriform?
Nailed it.
Piriform cortex, a collection of neurons located just behind the olfactory bulb that works to identify the smell. Smell information also goes to the thalamus, a structure that serves as a relay station for all of the sensory information coming into the brain.
Mm-hmm. The thalamus transmits some of this smell information to the orbitofrontal cortex, where it can be then integrated with taste information. What we often attribute to the sense of taste is actually the result of this sensory integration. Uh-oh.
Continuing the quote. God damn it. Continuing the quote, you've probably experienced that a scent can also conjure up emotions and even specific memories. This happens because the thalamus sends smell information to the hippocampus and the amygdala, key brain regions involved in learning and memory. End quote. So I think I'm a big fan of the hippocampus and the amygdala connections with the olfactory
Pretty cool.
System. Also, I just love that whenever I hear about how the brain works with like the rest of your body, I like can't believe how many little. It's like a little train.
Yes.
It's like it goes to so many stations before it like registers, but it happens so fast. Isn't that
incredible.
wild? That's like
incredible.
that was like 5 different little train stations.
It was insane.
It's like I'm explaining it to a 2-year-old. I'm sorry. I trust our listeners. You're all adults. And if you're not, good job for listening to this. We curse so much. I'm sorry.
Fucking welcome. Yeah.
You're fucking welcome.
Yeah, that's a really good analogy. Your brain is like it's like the tube in Japan. It's so fast.
It's so fast. Unlike the MTA where sometimes it's okay. And then most of the time it's not.
Yeah, the MTA is more like your intestine. It takes days to shit.
Oh my God. The MTA is like me when I'm drunk and I'm like trying to form a sentence. And I'm like, we should hot dog. That sounded sexual. It was me just trying to say I want a hot dog.
We should hot dog. Put it
we
on
should
a
hot
put
dog.
it on a tote.
We should hot dog, y'all. That's gross. Sorry. Ignore me.
We should
Talk more,
move
Jill.
on. Okay. So this olfactory bulb is essentially the fork in the road leading sense to the correct destination within the brain, essentially. And without it, researchers believed you'd have no sense of smell at all.
Oh.
A condition called anosmia.
Okay. I've heard of that. That sounds very familiar.
Yeah. Hopefully I'm saying it right too.
Sure.
So it turns out though, some people born without them totally have this sense.
That is wild.
Let's head on back now to that research team who has one volunteer in their pocket already. Remember the one?
Yes.
Okay. Now, to get a few more for their studies, quote, they then turned to data from the Human Connectome Project, a U.S.-based venture that's been collecting and studying the MRIs of healthy volunteers since 2009.
Oh, that's so cool. I wonder
Super
if I
neat.
can offer them mine. I
Yeah.
have an MRI, not to brag. I spent like $800 on it. And I'm like,
Fuck yeah.
I gotta use this somehow.
Submit it.
Yeah.
Submit that.
I'll submit it.
Submit that
Take
brain.
it.
Submit that brain.
Yeah.
Okay, now, out of more than 1,100 people in the project,
Yeah.
the team found 3 more healthy people
my
with
God.
the ability to smell but missing bulbs. All women and 1 left-handed.
Okay.
End quote from Ed Cara of Gizmodo.com.
All right.
So in total, they found 4 people in about 1,100
Oh my God.
that don't have bulbs. So if you're wondering about the stats, don't worry. They did the math.
Of course they did.
Yep. Quote, together, the data indicates 0.6% of women and 4.25% of left-handed women lack apparent olfactory bulbs, yet can smell.
How does this work?
Lack of apparent olfactory bulbs was not found in any men, end quote, from a news release over at eurekaalert.org.
I'm not sure if this is like a good thing or a bad thing. It's got to be
wild.
a good thing though, because like, oh, we can do stuff without a thing. Like, that's
It's
cool.
wild. 0.6%. Jesus, yeah. But the good times, they didn't end there.
Of course not.
The team was determined to find some physical explanation as to how these ladies could smell stuff. Like maybe their bulbs exist, but not where we usually find them? Question mark? Maybe? I don't know. So 2 of those volunteers went through a barrage of tests, MRIs, diffusion MRIs,
Yeah.
high ultra definition 3D imaging, whole brain voxel-based morphotometry. I did not look that up.
Voxel based. It's okay.
Yeah.
It sounds like a scan.
Yeah, morphometry. Voxel-based morphometry.
Are you sure? It sounds like you made it up.
Did I make that up? Maybe. I don't know. I swear to God, I didn't. That was one of the fucking tests. Okay. The team found, drum roll please, nothing.
Science.
They said no identifiable bulb was present. And good news, Dr. Marissa, I have a few of those MRI scans, and I'd love to show you.
And I'd love to see them.
Fuck yeah, let's look at these goddamn brains. Okay.
Let's do it.
Now, one scan is of a, air quotes, healthy brain with an olfactory bulb, or 2 actually. That's in number A. There are 2 scans belonging to the volunteers, the ones that don't have the bulbs, but they can smell. And the last scan, that's scan D, is of someone with no bulbs, and they have anosmia.
Right.
They can't smell.
Right. Okay.
They can't smell a goddamn thing. So please, tell us what differences you see. I labeled each again so you could use that as a reference as well.
Okay.
But yeah, what do you see in these goddamn scans?
I actually see something, and my mind is blown because it really looks like a lot of splotches. But you know how when you see a picture of a brain, it's got kind of like the little
Hemispheres?
It's splotchy.
Yeah.
The little wiggles and stuff.
Yeah.
The zigzags. The
folds?
The folds.
Yeah.
There we go. Never allow me to talk again.
Please, you're perfect.
But
You're perfect, goddammit.
Thank you. Okay, so in all of these, we're looking at kind of one point, which is the part we talked about, that part right between your eyebrows.
There you go.
And it's zoomed in the same place. So on the first one, which is the person, the quote-unquote healthy scan, you can see those little bulbs. It's really obvious. And the thing that's interesting about these is the bulbs are white. So I'm going to talk about some stuff that I see that I don't know if it means anything. So they're white as opposed to everything else that's kind of gray. In the second scan, which is the person with the missing bulbs who can smell, and so the 2 scans where the person is missing the bulbs and can smell, they don't have the bulbs, but it's white in that area, which I think is really interesting.
Yeah, but it's significantly smaller.
But
and it's
it's
missing a middle part. Yeah.
Yeah, it's missing the middle part and it's missing that bulb shape, but it's white in that area.
Yeah.
So I'm curious what that means. And then the person who cannot smell, who is definitely missing the bulbs, you can see nothing that looks like a bulb there, and it's also not white. There's just no action going on there. So
Yeah.
I don't know what that means.
Yeah.
Yeah.
So, yeah, it looks like to me that they have like a pocket, but that pocket is empty.
Yeah.
And it is a mystery. In sum, no answer was provided by these scans.
God damn it.
So it just confirmed what we already know. They ain't got no bulbs.
They ain't got no bulbs.
They ain't got no bulbs.
No
So,
bulbs.
moving on, the team then wondered just how accurate really is their sense of smell? Because they say that they could smell. So, Dr. Marissa, please tell us from eurekaalert.org what happened next.
I would love to talk about this. All right. Quote, the 3 volunteers also agreed to smell tests. These included subjective tests and objective tests that measure whether someone can pick up a scent, can identify scents, and can distinguish between scents. The 2 women who say they could smell performed within the norm for people their age, while the women with anosmia failed to detect most odors. End quote. So, yeah, the people who could smelled fine.
Totally fine.
The people who couldn't.
That's right.
Wow.
They are totally normal.
I was hoping it'd be one of those things where it's like we're both looking at the color blue, but their version is not the same. Like that sort of thing. Not quite color blindness, but it's just...
Yeah, slightly different. Well, here's a super interesting part. For the last experiment, the team asked those 3 volunteers and 140 other ladies of similar age to smell 10 samples.
Okay.
And from a sheet with a few descriptions on it, they were to choose the best one they thought described that smell to them. Once more, the 2 women without bulbs fell within the norms of the study. But, get this, they were, quote, unusually similar to each other in their smell perceptions, ranking closer than 96% of any other 2 participants, end quote, from Eureka.
So they're similar.
They're similar.
There's something going on.
Yes, they have similar experiences.
Remember when I went through that phase of blaming everything on aliens?
Yes.
It's about to start again. Maybe there's something alien going on here. I'm just saying.
Yeah, it is super weird. Could be aliens, that they are smelling things nearly identically, which is super weird. And this will need more investigation into why.
Yeah.
I mean, in the meantime, why the fuck can they smell at all?
Yeah.
Dr. Marissa, please tell us the vague theory.
I love a vague theory. All right, quote, the simplest interpretation of our findings is that these women were born without an olfactory bulb, but thanks to the extreme plasticity of the developing brain, they developed an alternative system somewhere else, not in the olfactory bulb, said Noam Sobel, senior author of the study. Although such plasticity is amazing, it is not out of the realm of what we have seen in human development. End quote. They've developed their own system.
Exactly.
They
you nailed it.
Yeah.
Yeah,
cool.
My friends, their version of an olfactory bulb is hidden away in their brain, and we can't find it, so it's amazing.
That's so weird, but good for them.
It is so weird, and it's going to get cooler and fucking weirder in the second half, because, my friends, after the break, what happened to another lady who's missing a big old chunk of her brain?
Oh, my God.
Like, for real. We're going to find out. Stay tuned.
Please do.
We're the All Creatures Podcast. Each week, Angie and I explore and share amazing details about the many animals we share our world with.
Plus, Chris and I are both PhD scientists and educators. So we do the deep dives in the scientific research and then come back and share what we learn in a fun and casual way. We also speak with other scientists, animal experts, activists, and many other conservation enthusiasts from all over the planet.
So you can find the All Creatures Podcast wherever you get your podcasts.
Have you ever wondered what really happened to Amelia Earhart or the lost colony of Roanoke? Do you ever find yourself scouring the internet for vicious Victorians and their murders by gaslight? Or perhaps you're just sick and tired of women being constantly misrepresented or plain lied about throughout history? If so, join me, Katie Charlwood, history harlot and reader of books, on Who Did What Now, the history podcast that's not your history class. Part of the Airwave Media Network. Available on Apple Podcasts, Spotify, or wherever you listen to podcasts. Adios, au revoir, au revoir, my friends. Bye-bye. I'll be seeing you.
Hey everyone, Jill Chacha here from Well, That's Interesting, and I am absolutely thrilled to tell you about Spotify for podcasters. I use it, I love it, and it all started by downloading the free Spotify for Podcasters app, which has all the tools you need in one place to record and edit your masterpiece of a podcast. Spotify for Podcasters also distributes your show to all major platforms. So when you hit publish, your episodes will stream not only on Spotify, but I'm talking about the Apples, the Googles, Stitcher, Good Pods, the other ones. You get the idea. And you can monetize your podcast with no minimum listenership required. You could also set up monthly subscriptions and record ads just like this one. So what are you waiting for? Download Spotify for Podcasters today and start changing the world. Oh, and please, stay interesting. And we're back.
We are so back.
We're so back. And my friends, we're all pointing to our left temple.
Oh,
there you go. Point to your left temple.
Okay, I got it.
All right.
I found it. I had to watch you do it first. I'm like, what is the left? I'm like, oh, that's right. It's the temple.
Left temple. All right. Now, if you would, please imagine the area behind it.
Okay.
Just beyond your skull. Imagine a few inches of space. Now make that space empty.
Oh, no. No. No, thank you. I need as much as I have. Don't take any.
That's right. It's missing. And I bet you have a few questions.
Yeah.
Like, is this part of the brain important? And what the fuck happens when it's not there? Well,
Okay. Is that part of the brain important? Let's just pause really fast on that question. I'm just assuming every part of the brain is important. The
That's
thought
good. That's good to
of
think.
losing, like I was watching a Nurse Jackie, which a hospital show the other day, and a girl had a bullet in her head and she was fine and talking, and I'm like, what?
yeah, it happens too.
And I'm like, I know this is fiction, but at the same time, I'm just like, but I thought the whole brain
yeah,
was like
it's very
pretty vital.
yeah, pretty much.
And so, okay,
Yeah,
that's
you
enough.
want to avoid things in the brain. Remember that kid who got impaled? We talked about that a
Yes.
few in-betweenies ago.
Yeah.
About the impalement. He was all right, and that's a really bad scenario.
That was a terrible scenario. It worked out really well for him and his mom. Jesus.
Yeah, Jesus.
Anyways.
Yes. So back to this. All right, now let's get acquainted with the left temporal lobe.
Okay.
Dr. Marissa, you and I have the fun task of telling our beautiful members of the flock what this section of the left hemisphere is responsible for and what happens when there's damage to it. What do you say?
I say yes, please.
All right, let's do it.
All right, let's get started. According to simplypsychology.org, quote, the left temporal lobe is associated with understanding language, learning, memorizing, forming speech, and remembering verbal information. End of that quote.
There you
and
go.
that's, I mean, I just have to add really fast. It sounds so important.
Yes.
Whoa.
Holy shit.
Holy shit.
Yeah. From flintrehab.com, quote, because many functions can be affected following temporal lobe damage, individuals may experience various complications that affect their ability to perceive and respond appropriately to their environment.
Oh my God.
For example, those with receptive aphasia or Wernicke's aphasia often feel like the people around them are speaking another language.
Stop it.
Likewise, Wernicke's aphasia, sorry, it's Wernicke's aphasia.
Nailed it.
It may also affect speech.
Okay.
Generally, individuals can produce words with normal tone and speed. However, their sentences usually do not make sense. Yeah.
Whoa. Mm-hmm. Whoa.
Reading and writing are also frequently affected, as these require language comprehension as well.
Holy shit. All right, continuing that quote. Temporal lobe damage may also affect an individual's selective attention and forming new long-term memories. Additionally, individuals may experience anger or aggression due to difficulties processing their surrounding environment. End quote. This is like important shit.
Oh, yeah.
Oh, man. Forming sentences.
Yes.
Memories.
Understanding others.
Attention. I mean, this is stuff. My temporal lobe might be a little like not what it once was, but I can't imagine losing a chunk of it.
Yeah, exactly. Yeah, so that sucks. It does. But now, my friends, may I introduce E.G.?
Okay. Yes.
E.G., who prefers to go by her initials, doesn't have damage to her left temporal lobe, she never had one. Dr. Marissa.
Oh my God. E.G.
Would you like to see a recent MRI scan of E.G.'s curious brain?
Yes, please.
All right, and of course, all MRIs today will be on our social media stuff, so please come on by and take a look at E.G.'s very curious brain. Dr. Marissa, what do you see or not see in this MRI?
Y'all have to look at this picture.
Woo!
You will laugh uncomfortably,
Yeah.
just like I did, and start sweating a little bit. But it's the, imagine a scan of a person's brain, a bird's eye view from the very top of the brain, and then just imagine, maybe a sixth of it on the left is just gone. Mm-hmm. It's just a big black hole in the shape of a bean. But yeah, I would say this is like 1/9 of the brain just not there.
Yeah.
It's just not there.
Yes.
Oh my God, E.G.
All right.
Are you okay?
I'm going to take this off the screen for a second.
Okay, thank you. Yeah, I was like, wow.
Yeah. So, as reported by Rachel Funnell over at IFL Science, quote, the missing lobe may have been lost in early life when E.G. was a baby, possibly the result of a stroke.
Oh my God.
The gap left behind is now filled with cerebrospinal fluid.
Okay.
End
Okay.
quote.
Baby had a stroke.
know.
Oh my God. No. Poor
I know.
baby.
Now, I'm super happy to report E.G., who is in her 50s and has been aware of her brain's condition for most of her life, speaks perfectly fine English and is fluent in Russian.
Oh.
According to Wired magazine, as part of a study at MIT, E.G. tested in the 98th percentile for vocabulary.
Amazing. She can speak more languages than I can.
Yes.
That's wonderful.
Yes. E.G. knows she's damn special, and bless her soul, she demanded neuroscientists should be testing the fuck out of her to get some answers.
Yeah, you're awesome, E.G.
Yeah, not just for her, but for science in general. So, stepping up to unravel the mystery that is E.G.'s head is Evelina Fedorenko, a cognitive neuroscientist also at MIT.
With the coolest name ever.
Oh, so good. Now, before we get into what study took place on E.G., Dr. Marissa, why don't you give us a little bit of a backstory about language development and why this particular study took place at all?
I would love to talk more about this. Oh my gosh. From Grace Brown at Wired.com, quote, language processing largely takes place in two major parts of the brain, the frontal and the temporal regions. The temporal lobes develop first, then the frontal areas develop later, at around 5 years old. At this point, the language network is considered fully mature. Because E.G.'s left temporal lobe is missing, Fedorenko's team had a chance to answer an interesting question. Are the temporal regions a prerequisite for setting up the frontal language areas? End quote. So we're like, can you continue with this sort of development without that
There you go.
ass piece?
That's right.
It's a big ass piece.
You need a
y'all.
big ass piece.
I'm not judging. I'm just like, whew.
Yeah. Yeah. So how the fuck do we even test for that?
Yeah.
Well, if E.G. showed activity in her left frontal lobe while she was performing certain word-related tasks, then that would suggest that frontal language areas can emerge without a pre-existing temporal lobe.
Okay.
And maybe that's why she's so kick-ass with language. It's just all in the frontal part. But if she didn't show any activity there, it suggests that a left lobe is necessary for the development of the frontal lobe's language abilities.
Right. Okay.
Funny that I tripped over that. So
It's a lot of lobes
It's a lot
and
of lobes.
language and blah, 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 blah. Yeah.
So E.G.'s brain was recorded while reading sentences and such, and the results were compared to 90 neurotypical controls. Turns out, E.G.'s frontal lobe showed no activity while she was doing language-related tasks.
Stop it.
Yeah.
I was scared they would be like, oh, if we actually, I was scared they would not weaponize it, but use it somehow and be like, oh, if we take out this part of the lobe, they'll concentrate more on the frontal lobe and then they'll be even smarter. But that blows my mind that without part of, I mean, it makes sense when you say it out loud, but without this certain part of the brain, you can't continue developing
Yeah.
a whole other part.
That's exactly right.
But then what is she using? Wow.
You're exactly right, Dr. Marissa. This means two things. One, left lobes do need to be in place for the frontal lobe language areas to develop. And two, for EG, both the temporal lobe and the frontal lobe functions must be taking place somewhere else.
Oh my God.
So, Dr. Marissa, by process of elimination, where the fuck else is left for all this stuff to go? Where do researchers believe all these functions are crammed into? Please tell us.
Let's talk about it. All right, from wired.com. I'm so excited. Quote, they concluded that in the absence of her left temporal lobe, the task of language processing seems to have shifted completely over to EG's right hemisphere. A single hemisphere appears to be sufficient to give her proficient language skills. End quote. What a brag.
Yeah.
I only need the right hemisphere.
Just need one.
Yep.
Yeah.
I learned 2 languages. Only half that. Only half.
With half my brain.
Only half. I was like, am I allowed to say half my brain? I don't know. Yeah, she's using half her fucking brain.
Yeah, I mean, she's got half her brain tied behind her back and she can still learn 2 languages.
That's the coolest thing I've ever heard. I hope she tells everyone.
Yeah.
That's so cool. I hope she tells everyone in 2 languages.
So, also, let's hear it for the right hemisphere for picking up the slack, you know?
Well done.
Fuck yeah,
Well
we've all been that
done.
hemisphere.
Yeah.
So-
Oh my God.
So, speaking of the right hemisphere, my friends, I got a plot twist for you. Hold on to your butts.
Okay.
EG has a sister,
Oh my God.
and you guessed it, she's missing her right temporal lobe.
What is happening with these lobes? Y'all. What?
And she's just fine.
Of course she is.
So Federico's team will be studying both EG and her sister in an upcoming experiment to try and understand what in the holy fuck is happening there. So please watch this space and thank your brain. The end.
I feel so privileged to have the use of my full brain.
Yeah.
And I mostly just use it to watch streaming content.
You're not alone.
But yeah, I am so impressed. What a badass.
Badass.
I realize this wasn't like her choice, but damn.
Pretty good.
What a good right hemisphere. Well
yeah.
done, EG. Nailed it.
That was a chef's kiss.
Yes.
So, and thank you for listening, rating, subscribing, telling your friends about people who's missing part of their brain.
Yeah.
And they're doing just fine.
They're doing just fine. Enjoy yours.
That's right.
Yeah.
And please, stay interesting.
Please do.